notes today are going to be functions defined by integrals. And we already talked about one in a previous video, but that was a graph. So now I'm just giving you just the function itself, and we're going to answer some of these questions here. Not long set of notes, just real quick. Functions defined by integrals. Okay. So we're given this function for values of x is the graph. So for what values of f is the graph decreasing? Okay. So again, this is area. So anytime we have a integral inside of a function like this, so it's f of x where one of the bounds is x, this is area. So for decreasing, I actually want to find the derivative of this, okay? So yeah, this one isn't, I'm just trying to look, this one isn't as weird as the graphing one. So I need to find f prime. Okay, that's all I need to do, and I'll go from there. This one isn't as confusing as the graphing one, a little more straightforward. So I'll find the derivative of this. So what is the derivative? Well, remember you got to plug the x into all the t values. So we're going to get x plus 2, x minus 3 all squared, times the derivative of whatever I plugged in. So the derivative of x is just 1. So that's as simple as x plus 2, x minus 3 all squared. And if I want to see something that's increasing or decreasing, I got to set equal to 0, find my critical points, and let's have a good time here. So I'm going to get x to be negative 2 and 3. So bounds are from negative infinity to infinity. So I'm going to have at negative 2 and at 3. So all I need to do now is just plug in my points into my sign chart, see where it's negative, and that's all I'm really looking for. And we'll do an explanation as well. So from negative infinity to negative 2, if I plug in a number like a negative 3, for instance, I'm going to end up getting a negative value. Yeah, negative value. Yeah, and then if I plug in like a 0, I'm going to get a, this is always going to stay positive. It's going to get a positive value. If I plug in like a 4, it's going to be a positive value again. So where's this decreasing? Well, we are decreasing in the interval of negative infinity to negative 2. And always state a reason, always justify for these, no matter what. Always justify. You don't, it doesn't have to say to justify for you not to lose points for not justifying it. So why? Because, and by the way, this is a sign chart of f prime, because f prime is negative. And that's all you need. That's it. Okay. All right, next one. So suppose that we have this 3x squared minus 12, and this equals an integral. Okay, what is f of x? So in this case, because I'm giving you a function of area, this is actually the derivative. Okay, this is the derivative of my function of area. So since this is the derivative, I have to find the derivative. So I'm going to find the derivative of 3x squared minus 12, which is going to be the derivative of this over here. Okay? So just doing the right side real quick, this is f of x. That's all it is. That's it. This is f of x. And then the derivative on this side is going to be a derivative of 3x squared is 6x. And that's actually it right there. So that's my answer. I'm waiting for it to get harder, but I guess not. Don't worry, it will on part B. Okay? That was it. Just, again, the whole idea, it's conceptual. It's not difficult to do. It's conceptual. Okay, this is the derivative of the area, and then I'll just take the derivative. Okay? So let's go ahead and find the value of c here. So what it's really asking for us to do is to actually solve for this problem right here. So I know what f of x is. So since I know that, I can actually solve for t here. So since f of x is equal to 6x, that's going to tell us that f of t is equal to 6t. That's what it's telling us. So I'm going to go ahead and plug this into this formula right here. So I'm going to get 3x squared minus 12 equals the integral from c to x of f of t is just 6t dt. That's it. So now, really, I'm just going to leave this left side alone as I work on this right side, and then I'll get to that left side at the end. I'm going to just go through and do this problem where my bounds are c and x. So essentially, I kind of have like two variables, but I'm trying to solve for the c variable. So antiderivative of 6t is 3t squared. Evaluate that from x to c. I'm going to get 3, plug in the x, 3x squared, minus plug in the c, 3c squared. Okay. Yeah, so if you notice right here, I have 3x squareds on both sides. So actually, those can cancel out. And I'm left with just a negative 12 equals negative 3c squared. Oops, sorry. Florida is calling me. No, anybody from Florida. Sorry about that. So go ahead and solve for c here. So I'm going to get 4 to equal c squared. C is going to equal plus and minus 2. But yeah, I don't think we need to check that at all. I'm trying to see if we do. Yeah, you can go through and check it. So if you integrate from negative 2 to x of f of t dt, so this is just our check work. So go ahead and check it. So this is the same thing as integrating from negative 2 to x of 6t dt. This is going to give you 3t squared from x to negative 2. And this is going to end up giving me 3x squared minus, plug in the negative 2. It's going to be 12. Yeah, so that works. And then you can do the same thing for 2. You can check that. But the 2 is going to work out because it's positive, so it's not the negative one's the one that might have tripped us up a little bit. So we're going to get 3t squared, evaluate that from 2 to x. I'm going to get 3x squared minus, and then you plug in the 2, 12. They both work. So plus and minus 2, we are all good for that. And that's it. Not a long video, not long notes, just kind of problems that you might see just by giving the function instead of a graph. That's it.